In this video, we're going to continue with the review for test 3. And this video will include questions from exercises 11 through 20. In this exercise, we're asked to find the probability of not being between 18 and 20 years old based on the probability distribution that we have here of the age of voters. So not between 18 and 20, what that means is that it will be excluding the first information that is provided on the table. So we need to find the numerator and we need to find the denominator. It's good to know the sum of all the frequencies that were given, in this case in millions of dollars, the amount of voters based on their ages. So we will be adding the frequencies and that will be the denominator. So when you add them all up, you will still include the one that we are asked not to include. In this case, not between 18 and 20. It will not be part of the numerator, but it will be part of the denominator. So it's 8.7, 8.9 plus 24.2 plus 24.9 plus 51.4 plus 26.1. So these are the sum of the frequencies: 8.7, 8.9, 24.2, 24.9, 51.4, 26.1. And this total will be my denominator. Now I cannot include the 8.7 from the frequency because that's what it says in here, not between 18 and 20. So the remaining values from the frequency are the ones that will become the numerator. So 8.9 plus 24.2 plus 24.9 plus 51.4 plus 26.1, and that will become my numerator, 135.5. So my probability will consist of the numerator being 135.5 divided by 144.2. And according to what is indicated below the box, they want you to round it to 3 decimal places. So this 9 is followed by a 6, so I need to make this 9 a 10. So the 0.939 becomes a 0.940. The 39 becomes 40. Let me make sure that I have the values that we are including. So it's going to be 0.940. And that 0 at the end should be optional. They will take it 0.94. So in this exercise, question number 12, a probability experiment consists of rolling a 6-sided die and spinning the spinner shown at the right. The spinner is equally likely to land on each color. Use a tree diagram to find the probability of the given event. Then tell whether the event can be considered unusual. So the event is rolling a 3 and the spinner landing on green. Rolling a 3 in a 6-sided die, there is only one number that is a 3. So that is going to be 1 out of 6. And the spinner landing on green, there is only one green out of 4. So in this exercise, since it has an and, it will indicate that I have to multiply those probabilities together. So rolling a 3, when it is a 6-sided die, you have one number that is a 3 out of the 6 possibilities. And then we are multiplying this. I prefer to enclose this in parentheses. So 1 out of 6 is the probability of getting a 3. Multiplied by, there is only one green out of the 4. So it's going to be 1 out of 4 is the probability of landing on green. So you multiply these two and they want you to round it to 3 decimal places as well. So 0.041, and that 1 is followed by a 6. Therefore, that one needs to become a 2. So that is going to be 0.042. Let me verify that. 0.042, the one, correct. So now we move on to question number 13. Actually, we continue with number 12, and we have to decide whether it is unusual or not. It will be unusual if the probability is less than 0.05. And here we have 0.04, so it is unusual. So we're going to have to choose between the two options for unusual. And here it says yes, because the probability is 0.05 or less. And D, yes, because the probability is greater than 0.10. So the correct answer is B. The probability 0.042 is less than 0.05. So next, question 13. You're planning a 3-day trip to Seattle, Washington in October. Use the fact that on each day it could either be sunny or rainy, and that each day is equally likely to be sunny or rainy to answer the following question. What is the probability that it rains all 3 days? So what that means is that it will rain the first day and the second day and the third day. So it will be a product of 3 probabilities, and the probability of raining is it can either be sunny or it can rain. So again, I prefer to use parentheses. So for the first day is 1 out of 2 chance. Then multiply by the second day is also 1 out of 2. It either rain or is sunny. And it is for 3 days, so 1 more day. That third day, it can either be rainy or sunny, so 1 divided by 2. So it's a product of 1/2 times 1/2 times 1/2. And they want you to type an integer or a decimal. So an integer or a decimal, so that means that is 0.125. That will be the decimal that we will use. Question 14. For the given pair of events, classify the 2 events as independent or dependent. Waking up and finding the alarm clock blinking 12, getting to class late. So it is possible that the alarm clock did not go off because you usually don't have class just at 12, and if it is blinking, it's usually that you may have lost power and it does not display maybe the time. So the 2 events can be dependent. It can cause you to be late to class. So the 2 events are dependent because the occurrence of one affects the probability of the occurrence of the other. The 2 events are dependent because the occurrence of one does not affect the probability of the occurrence of the other. So that is the definition of independent mixed with the dependent. So the 2 events are dependent because the occurrence of one affects the probability of the other. Next, question 15. A coin is tossed and a 6-sided die number 1 through 6 is rolled. Find the probability of tossing a tail and then rolling a number greater than 2. So the probability of tossing a tail is 1 out of 2. Okay, so, and again, I prefer to enclose that in parentheses. That's 1 divided by 2. And then it says, notice that in here that it says and, so that means multiply by, then rolling a number greater than 2, and it is a 6-sided die. So a number greater than 2, the options are the number 3, the number 4, the number 5, and the number 6. So therefore, there are 4 choices out of the 6 numbers in the 6-sided die that are greater than 2. So it will be 1 out of 2 for the probability of tossing a tail and 4 numbers out of 6 for the probability of rolling a number greater than 2. And they want you to round these answers to 3 decimal places. So this one is going to be 0.123. Next, question 16. A doctor gives a patient a 70% chance of surviving bypass surgery after a heart attack. If the patient survives the surgery, then the patient has a 50% chance that the heart damage will heal. Find the probability that the patient survives the surgery and the heart damage heals. So notice in here it says and. So and must inspire to multiply. The and can be implied or it can be stated like in the other one. So the first one, it has a chance of 70%. You can treat it as a 70. Let's treat that as a 70 as a percent. And then it says, so the probability of surviving by passenger surgery is 70% chance, and it's asking for the having the bypass surgery and the heart damage healed. So the heart damage healed is 50%. So it's going to be the 70. Let me get the clear here, delete. So it's going to be 70 times 0.50 times 50%, because they want the probability as a decimal. Let me do it as a decimal. So it will be 0.70. Let me clear this. It's okay. You don't need parentheses if you're not using fractions, so I don't want to confuse you. So if I see decimals, I don't use the parentheses. So 0.70 times 0.50. And they want you to round it. It says type an integer or a decimal. So in this case, it's 0.35. It doesn't tell you the amount of decimal places on this one. Number 17, determine whether the following events are mutually exclusive. Explain your reasoning. So mutually exclusive, basically, they do not overlap. They don't have any outcomes in common. So event A states that randomly select a male that is a political science major. So you have to compare that event with event B, that is randomly select a political science major who is 19 years old. So these two events are not mutually exclusive because you can find a male political science major that is 19 years old. So this one will be are not mutually exclusive, since it is possible to select a male political science major who is 19 years old. And again, this one was a drop-down menu. Number 18. The table below shows the results of a survey that asked 1,074 adults from a certain country if they favor or oppose a tax to fund education. A person is selected at random. Complete parts A through C. So parts A is asking for find the probability that the person opposes the tax or is female. So the probability that it opposes the tax or is female. Okay, so the probability of opposing the tax is, every time you see an or, it will indicate that you will have to add information, the probabilities. So the probability of opposing the tax, so we're going to take it 631 out of the total that we have, 1,074, and then added to the probability of females is 567 out of 1,074. And if you notice, we counted females and oppose twice because oppose and female are 300s. So you have to look, these two events are not mutually exclusive. So we need to remove the overlap. So in essence, we are going to do this. It's going to be 631 plus the females that are 567 minus the overlap, that is 300s. Those are the ones that oppose and are females. And this is my numerator divided by the overall denominator of 1,074. And they want you to round to the nearest thousand. Nearest thousand means 3 decimal places. So 0.836, the 6 is followed by a 1, so it remains 0.836. And there are more parts in this question. The next one, find the probability that the person supports the tax or is a male. Supports or is a male. So we're going to follow a similar process. So we're going to add the amount that supports, the amount that is male, and then subtract the one that supports and it is a male. So the numerator is going to be the amount, the total amount that supports, and that is 407. 407 added to the amount of males, that is the total is 507. And then you have to subtract the supports and male is 170. So you get 744, and that's your numerator, and the total is 1074. And they want you to round the answer, this one as well, to the nearest thousand. That means 3 decimal places. 0.692, that 2 is followed by a 7, so we're having to increase the third digit to a 3, 0.693. So now we're in the last section. It says the probability is not unsure or is a female. It's not unsure or is a female. So if it is not unsure, that means that it supports or opposes, because it's not unsure. So we're going to add the total for supports and opposing. That is 407 plus 631. And it says or female, so we'll add the total for females, 567, and we have to subtract the 2 that we added twice, because the 237 and the 300s are there twice already included in what we when we added these two numbers. So I have to subtract the 237 and I have to subtract the 300, and I also have to subtract the 30 minus 30, because that is part of the unsure. So this is my numerator, and I have to divide it by the overall total, that is 1074. And let me make sure, 407, 631 plus 567 for the females, and then we subtracted 237, 330. And that gives me 0.966, and that should be the 3 decimal places that we enter, 0.966. Let's see. Know that if events A and B are mutually exclusive, the rule can be simplified. So let me see what was my mistake. It is not unsure, or, you know, my interpretation of this is always, it says it's not unsure or is female. So I cannot, it's not female. So I cannot include the females, because it implies that it's not unsure or is also not female. Okay, I recall making that mistake before. Okay, so if it's not unsure and it's not female, that means that is males, right? And divided by the total. So it's only male, support, and oppose. 170 plus the oppose, that is 331. I cannot include the not unsure, and I cannot include the females. So if I just focus on male support and male oppose, I don't have to subtract, as those two are mutually exclusive, and then I just divide it, add them, and divide it by the total. Let me see. The statement of this question can tend to be confusing because it's not unsure and it seems to, we need to imply that it's also not female. So let me double check my theory on this one. Okay. Okay, so let's work on this last question, this last part. Again, in this part, it seems that the best way to approach this one is using the complement, but I was getting word parts of the question and it will make it a lot longer, and that's why I was getting it wrong. Okay, so it's not unsure or female. We're gonna work with the complement will be is not unsure or is female is going to be the probability of being sure and being a male. So the probability that you are defined and you are a male. Okay, so let me get the calculator. So the complement of this is going to be the probability of is not unsure or is a male. The complement is the probability of being unsure and male instead of female. So being unsure and male is 6 out of 1,074. So you look for the intersection of the complement. So males and unsure, being unsure, which is a complement of, is not unsure or is a male. The complement is the probability of being unsure and male. So unsure and male is 6 out of 1,074. So this is going to be, since it is the complement, it's going to be 1 minus, and I recommend that you enter this in parentheses, 6 divided by 1,074. And the reason we're doing 1 minus is because we're using the concept of complement. And since the probabilities, they have to add up to 1, that's why if the overall total is 1 and I'm working with the complement, removing what I'm not being asked to find to get what we are looking for. So in this exercise, the answer is 0.994. It will be, again, by using the complement, the concept of the complement. So next question, number 19. The table shows the result of a survey in which 250 males and 250 female workers ages 25 through 64 were asked if they contribute to a retirement savings plan at work. Complete parts A and B below. Click the icon to view the survey results. So we're gonna look at the survey and read the question. It has multiple parts. Find the probability that a randomly selected worker contributes to a retirement savings plan at work, given that the worker is male. So the key word here is given. So what that means is that this is a conditional probability exercise. So what is after given becomes your denominator. So here, given that the workers is male, that means that my denominator is going to be 250. And what that also means is that I am only looking at this row of males. My denominator will be 250. My numerator is going to be what is before the word given. And in this case, it says find the probability that a randomly selected worker contributes to a retirement. So it's going to be 123 out of 250. Again, when you're working with a conditional probability, it is a reduction in the sample space. You do not use the overall number in these questions. So in this exercise, it's going to be 123 out of 250. So let me clear the screen, and it is 123 divided by 250. Let me make sure that I'm matching the values from the table. Okay, so it says contribute and male 123, overall is 250, enter. And then we look and see how many. They want 3 decimal places. So in this case, it's going to be 0.492. 0.492 for part A. So we move on to part number 2, and it seems that is the last part. Find the probability that a randomly selected worker is female, given that the worker contributes to a retirement savings account. So if it says female is before the word given. After the word given, it says contributes. So therefore, we're working with this row. What is after given? That means this is my row. These are the only numbers that I can use. And it says that is female. So out of the 282, 159 are females. So in your calculator, 159 divided by 282. And that is, and we need to round it to 3 decimal places. And that is 0.56, and the 3 is followed by a 4, 0.564. Okay. And the last question for this video, decide whether the random variable x is discrete or continuous. And again, in here, this number tells you the section that is coming from. So if you have questions on these exercises, you can go back and review the PowerPoint or any virtual classroom session that we have done to go back and review those topics. So X represents the number of dependent children in a household. So is the random variable discrete or continuous? So discrete are the ones that are countable, and you do not need any particular instrument to measure it. And continuous, you do need an instrument to measure. Like if they ask you, oh, how much weight have you gained? So you have to look at a scale if you want to give a specific answer. In this case, the number of children, you will answer, oh, I can count them. Okay, so I have 1, 2, 3, 4. So since this is an event that is a countable variable, what is describing here, it is a discrete variable. Okay, so we're going to stop the video here, and we're going to